Hello students, today we'll be discussing the next part of the P block elements, group 15, oxidation state. Today's video will be very interesting one and very important one because if you understand how to calculate oxidation state and other chemical properties, then it will be very easy for you people to do the concepts of group 16, 17 and 18. So let us begin with oxidation state of group 15 elements. We know that group 15 elements, they have the outermost configuration NH2NP3. So there can be two possibilities with their 5 valence electrons. They can either lose 3 electron from NP orbital or they can gain 3 electron. So we can have oxidation state from, let's say, +3 to -3. There can be two types of oxidation states. Along with that, element from group 15 can lose all these electrons from NH2 and NP3 and can go for +5 oxidation state. So there are variety of oxidation state +5, +3 and -3. So I can say there will be two types of oxidation state, positive oxidation state and negative oxidation state. In this video, I will be sharing certain tricks also. So the first trick is that for any group in P block, the upper elements, they always show high oxidation state, and the lower elements of a particular group in P block, they show lower oxidation state. And this low oxidation state generally differ by digit of 2. Why? Because they will be losing these NH2 electrons also. Now, if any element goes for a higher oxidation state, the compound formed in that case, it will be acidic in nature and it will be covalent. Whereas, if the compound goes for lower oxidation state, then if the element of any group from P block, it goes for lower oxidation state, in that case the compound formed, it will be basic in nature and it will be ionic. Now you have to remember this whole trick. It will be applicable to all the groups of P block and all the oxidation states. So coming to negative oxidation state, when the element will show negative oxidation state, when it will gain or it will accept 3 electrons. We are talking about group 15 elements. So when it gains 3 electron, it will show negative oxidation state, that is -3. Now we have to remember that nitrogen, being small in size, it will easily accept the electron and shows -3 oxidation state. So nitrogen shows -3 oxidation state. But as we move down the group, we know the atomic size increases. Atomic size increases, therefore tendency to lose electron will increase or tendency to gain electron decreases, and therefore tendency to show negative oxidation state will decrease. In other words, we can say the metallic character increases and therefore bismuth can never show -3 oxidation state. Bismuth, it will be stable only in +3 oxidation state. You have to remember this statement. Now why bismuth shows +3 oxidation state? The reason is inert pair effect. About that we'll be discussing later. The next is positive oxidation state. The highest positive oxidation state shown by group 15 element is +5. This will be the highest positive oxidation state of group 15 elements. And just now I have told you that if any element exhibit +5 oxidation state, then that compound becomes essentially covalent. Why? Because it is showing higher oxidation state. These concepts are very important one. For example, PCl5, it's a covalent compound. Okay, so overall if you want to put the things in a nutshell, nitrogen and phosphorus, the highest oxidation state shown will be +5. Other elements like arsenic, antimony and bismuth, it will show +3 oxidation state. So at the starting I have told you that the lower elements will show less oxidation state or lower oxidation state, which will differ by the unit of 2. And the reason, it is because as we move down the group, the atomic size increases. There is a presence of d and f orbital, and therefore the s orbital, inner s orbital, do not participate in bonding, and that is what we call as inert effect. So these keywords must be mentioned in your answer when reasoning types of question are asked. For example, the question can be asked, why bismuth shows +3 oxidation state and not +5? Bismuth being larger in size, it will show inert effect and therefore it will be stable in +3 oxidation state. So overall what we can say, the common oxidation state or common group oxidation state for group 15 is +5, and the lower members, they show low oxidation state, and this less oxidation state differ by unit 2. But there is an exception to this rule. Chemistry is full of lots of exceptions. So what is the exception? It is of nitrogen. Nitrogen is stable in -3 oxidation state. It cannot form +5 oxidation state. Remember this concept, nitrogen cannot form +5 oxidation state. Why? Because of absence of vacant d orbital. Since d orbital is absent here, we know the configuration of nitrogen is 2s2 2p3. So 2d orbital is not there, 2d orbital is absent, and therefore we can say nitrogen cannot extend its covalency beyond 4. Or we can say NCl5 do not exist. Why NCl5 do not exist? Because in this nitrogen will exist in +5 oxidation state, whereas NCl3 is a known compound. Okay, why? Because in NCl3 nitrogen will be in +3 oxidation state. So what's the main concept we have to remember here? If the element in a particular compound exhibit higher oxidation state, then that compound will be covalent in nature and acidic. But if the element in any compound exhibits low oxidation state, then it will be ionic and basic. How can we remember? HCA. So just remember the alphabet HCA, Lib. So if you remember these things, calculations of oxidation number and answering reasoning type questions will be very easy for you people. One example of higher oxidation state I have already given, that PCl5. In PCl5, phosphorus is in +5 oxidation state, higher oxidation state, therefore covalent, whereas BiF3, BiF3, bismuth is in +3 oxidation state, which is a lower oxidation state. Therefore, it will be ionic and basic in nature. So that was all about the physical properties of group 15 elements. Now we will be moving to chemical properties. But before we understand chemical properties of group 15 elements, we have to know about the anomalous behavior of nitrogen. We know nitrogen is an element of second period with electronic configuration 1s2, 2s2, 2p3. And all the elements of second period, they show anomalous behavior. What is anomalous behavior? They have exceptionally small atomic size. They are highly electronegative. We know nitrogen is the third most electronegative element of periodic table. Okay, then it has high ionization enthalpy and the d orbital is absent in these elements. And due to this anomalous behavior, lots of properties of nitrogen, they are affected. So what is the impact of this anomalous behavior? The first one, nitrogen forms only p-pi multiple bond. We know nitrogen has only p orbital as its outermost orbital. So it can overlap with p orbital and can form p-pi multiple bond with itself and other elements. What will be the consequence? As a result, nitrogen will exist as a diatomic molecule. This is your give reason question, that why nitrogen exists as a diatomic molecule. That because of the small size and high electronegativity, nitrogen forms only p-pi multiple bond with itself, and therefore nitrogen exists as a diatomic molecule, as well as that results in the formation of a triple bond. Now when nitrogen undergoes p-pi bonding, it forms a triple bond. These bonds are held together by weak van der Waals forces and these can be easily broken. And therefore nitrogen exists as a gas at room temperature. This is your next important give reason question. The next property is catenation. We know what is catenation. Catenation is the self-linking property. The elements of second period, they show catenation, but nitrogen will have less tendency for catenation, especially when we are comparing with the element like phosphorus. Now reason, the small size of nitrogen. Due to small size of nitrogen, the single bond becomes very weak. There will be interatomic repulsion, large interatomic repulsion. In what? Nitrogen has, entomolecule has lone pair on it, and this lone pair, they will cause the repulsion, and therefore nitrogen cannot form single bond. As a result, its catenation tendency becomes very less as compared to that of phosphorus. So catenation, what we can say, the order that of phosphorus is greater than that of nitrogen. Now coming to reactivity, we know nitrogen has a triple bond between, nitrogen molecule has a triple bond between two nitrogen atom. As a result, what will happen? Bond dissociation enthalpy becomes very large, near about 941.4 kilojoule mole per mole. Large amount of energy is required to break this triple bond, and therefore nitrogen becomes inert and unreactive in the elemental state. Again, this is your important give reason question. This is also an important give reason question. Based on this topic, you will have lots of reasoning questions. But the same thing, if we compare it with phosphorus, phosphorus is more reactive than nitrogen. Why? Because phosphorus single bond is a weak bond, can be broken very easily, and therefore phosphorus easily catches fire when it is exposed to air, and therefore phosphorus is stored in water. The next property is covalency. We know that in nitrogen the d orbital is absent because of its configuration 2s2 2p3, and it will impact its bond formation. That is, nitrogen can show maximum covalency of 4. That means nitrogen can form at the most 4 bonds. and therefore we'll say the pentahalides like NCl5, NF5 do not exist. Again I will say this is your important give reason question, that why compounds like NCl5 and NF5 do not exist. Because nitrogen cannot extend its covalency beyond 4, whereas the other elements of group 15, they have d orbital present in them, therefore can easily extend their covalency beyond 4 and can form pentahalides. In other words, I will say the pentahalides of nitrogen, they are not stable one. So the pentahalides of nitrogen, they are not stable one. So this is how the small size, the high electronegativity and other anomalous behavior of nitrogen makes it a totally different element as compared to other elements of group 15. Moving on to the next one, d pi p pi multiple bond. That means nitrogen cannot overlap with other vacant d orbital. Due to absence of d orbital in nitrogen itself, it cannot form d pi and p pi multiple bond. It will result in the consequence that nitrogen cannot form the complexes like R3N double bond O or R3N double bond CH2. Now CH2 can be any alkyl group. On the other hand, other heavy elements like phosphorus and group 15, they can undergo d pi p pi bonding, and therefore they can easily form compounds like or complexes like R3p double bond O or R3p double bond CH2. Again, it's a most expected question. Nitrogen is the most non-metallic element of group 15. Reason? Due to high electronegativity. The last consequence of anomalous behavior of nitrogen is that the trihalides of nitrogen, they are stable but not the pentahalides. Only NF3 is stable. Otherwise the trihalides of nitrogen like NCl3, NBr3, Ni3, they are unstable. But the other elements of other trihalides of elements of group 15 elements, they are stable one. Now why NF3 is a stable one? Because in NF3 the bond strength of nitrogen and phosphorus is high, and therefore it cannot be easily broken, or I will say it is an exothermic compound. So this was all about the anomalous behavior of nitrogen and its impact on various properties. Now we'll begin with chemical properties of group 15 elements. So we will begin with the first chemical property, that is reaction with hydrogen. When any element from group 15 reacts with hydrogen, it forms hydride. Okay? And these hydrides are generally gaseous hydrides. In these hydrides, the element is sp3 hybridized. E stands for the element from group 15, and it is pyramidal in shape. Why they are pyramidal in shape? Because to avoid repulsion between lone pair and bond pair. Okay, so elements from group 15, they form hydrides like ammonia, phosphine, arsenic hydride, antimony hydride, bismuth hydride. Every element will have a lone pair present on it. Now we have to study the characteristics of these hydrides. So these are the properties of hydrides which we are supposed to discuss: melting point, boiling point, element hydrogen distance, bond angle, bond formation energy, bond dissociation enthalpy, etc. We'll begin with the first one, bond angle. As we can see, the bond angle from ammonia to phosphine, it decreases more further. Especially if we see the bond angle in ammonia and phosphine, there is a great difference between these two bond angles. So, bond angle decreases down the group for hydrides. What is the reason behind that? As we move down the group, we know electronegativity of central atom decreases. As a result, repulsion between lone pair and bond pair decreases. Therefore, the bond angle also decreases. Like we can see in ammonia and phosphine, there is a repulsion between lone pair and bond pair of nitrogen and hydrogen and phosphorus and hydrogen. Nitrogen being smaller in size, the repulsion becomes much more and therefore bond angle increases. The next characteristic is basic strength. We know that there is a presence of lone pair on hydride of every element. So the presence of lone pair makes them basic in nature. This lone pair can be donated. As they can be donated, therefore they will act as Lewis base. Now when we talk about ammonia and bismuth hydride, as we move from ammonia to bismuth hydride, the basic strength decreases, or I will say basic character decreases. An important concept. That means ammonia becomes the strongest basic and bismuth hydride becomes the least basic. This question is repeated so many times in your board exams. Now the question is, why ammonia becomes strongly basic in nature? We know nitrogen is small in size and therefore the lone pair gets concentrated in small area, and therefore these lone pair can be donated very easily. As a consequence, ammonia becomes strongly basic as compared to bismuth hydride. Remember, this is one of the important give reason question. Again, this one also for the bond angle. The next character is thermal stability. Now, what do you mean by thermal stability? Thermal stability means on providing heat, whether the given compound will dissociate or decompose easily or not. That is what we call as thermal stability. Thermal stability is directly proportional to atomic size. Now, as the atomic size increases, the element and hydrogen bond strength will decrease. As a result, thermal stability will increase. It will decrease. This can be easily clear from the bond dissociation enthalpy of ammonia and bismuth hydride. Bismuth hydride will be a thermally stable compound as compared to ammonia. The next characteristic of hydrides is reducing character, or the tendency to act as a reducing agent. Now, what do you mean by tendency to act as a reducing agent? The tendency of donating hydrogen atom. Now, if we compare ammonia and bismuth hydride, there is a great difference in the size of bismuth and hydrogen. So, bismuth and hydrogen, that bond length, bond strength is a weak one, and therefore hydrogen can be donated easily. Whereas on the other hand, we know nitrogen is small in size. So nitrogen hydrogen bond strength will be comparatively higher. Therefore, hydrogen cannot be donated easily. And ammonia will be weak reducing agent. Whereas bismuth hydride will be strong reducing agent. These concepts are very important, and again I am repeating, all the questions related to concepts of hydrides, they are frequently asked questions. Now, if we compare the thermal stability and reducing character, we have seen that bismuth hydride is a thermally stable compound. Ammonia is comparatively not a thermally stable compound. Bismuth hydride is a strong reducing agent. Ammonia is a weak reducing agent. So, I can say reducing character is inversely proportional to thermal stability. Again, this will be the important one. The next concept is melting point and boiling point. Have a look on the data of melting point and boiling point. When we move from ammonia to phosphine, the melting point or boiling point first of all decreases. But as we move ahead for hydrides of arsenic, antimony and bismuth, again the melting point or boiling point increases. Now there is a variation in this case. So when we are discussing about melting point and boiling point, we have to consider the size. We know down the group, the atomic size increases. As the atomic size increases, what will happen? The London forces or van der Waals forces, they will increase. Therefore, boiling point will also increase. So as we move down the group, the boiling point should increase. But there is an exception, as we have seen just now. There is an exception of ammonia and phosphine. Now, why there is an exception in this case? Nitrogen, we know being third most electronegative element, can form hydrogen bonding very easily. You can see here. And as the hydrogen bonding is there, obviously we know wherever hydrogen bonding is there, boiling point increases. Whereas in case of phosphine, there is no hydrogen bonding. In case of phosphine, hydrogen bonding is absent. Whereas in case of ammonia, the hydrogen bond is present. And as a result, the boiling point of phosphine becomes less than that of ammonia. So if I want to write the sequence, phosphine will have the least boiling point as compared to ammonia, as compared to arsenic hydride, antimony hydride and bismuth hydride. This is what the sequence we have already seen in that table. So these are the properties of all hydrides of group 15 elements. That is, this is how the element of group 15 react with hydrogen and shows the different properties. Now here I have put all the properties in a nutshell along with their reasons. This is the most important table of all the groups for P block. If you remember these key terms, then you will be able to answer questions related to hydrides of, let's say, group 15, 16, 17 or 18. This will be applicable to all group. So I will say you have to learn these concepts, and remember in your give reason type of questions, these keywords must be present. Now based on this hydrides concept, we have reasoning type question, as we have arrange in order type question, arrange in increasing or decreasing order type of questions. Next chemical property is reactivity towards oxygen. The elements of group 15, they form two types of oxides, either E2O3 or E2O5. In E2O3 oxides, the element will be in +3 oxidation state, and in E2O5, the element will be in +5 oxidation state. Now, as you can look at this table, nitrogen forms maximum number of oxides. Comparatively, the other elements do not form that many oxides. Reason? Because nitrogen can form p-pi bond with oxygen, and therefore it forms large number of oxides. So this will be your important give reason question. From our basic knowledge, we know the oxides, they are either acidic or basic in nature. Now the question is, these oxides will be whether they will be of acidic nature or whether they will be basic in nature. For this, we will revise the concept which we have seen just before few minutes, that if the compound form oxide in the higher oxidation state, then it will be acidic in nature and it will be covalent. On the other hand, if it forms the oxide in the least oxidation state or lowest oxidation state, then it will be ionic in nature and it will be basic in nature. Now, why this difference comes as the oxidation state changes? The answer lies in Fajon's rule, which we have studied in class 11th, that smaller the size of the cation or larger the size of the anion, greater will be the covalent character. So this trick will help you to find out the acidic or basic nature or the covalent or ionic nature of any compound. So nitrogen and phosphorus oxides, they are acidic in nature. Arsenic, antimony, they form amphoteric oxides, and bismuth forms basic oxide. Now again, this will be a trick for remembering the oxides of any group from P block. That is, the upper elements, they will always show acidic oxide, the middle elements will show amphoteric oxides, and the lower elements will form basic oxides. The last chemical property is reactivity towards halogen. Elements of group 15, they form halides of two types, EX3 and EX5. In EX3, the element will be in +3 oxidation state, and EX5, the element will be in +5 oxidation state. So these are called as trihalides, and EX5, these are called as pentahalides. Just now we have seen that in case of nitrogen, only trihalide is stable. In that also NF3 is stable. Other trihalides are not stable. They are unstable, or I will say they are explosive also. But the other elements, their trihalides are stable. One more thing. Now this is a compound where the element will show lower oxidation state. Lower oxidation state means it should be ionic in nature, but there is an exception. Exception is bismuth fluoride. Bismuth fluoride is covalent in nature. Coming to pentahalides. Pentahalides, nitrogen cannot form pentahalides because of absence of d orbital. It cannot extend its covalency beyond 4. But the other elements, they can form pentahalides like PCl5, PF5, etc. And all pentahalides, since the element is present in the highest oxidation state, they are covalent in nature. Whereas the trihalides should be ionic in nature with the exception of bismuth fluoride. So this was all about the properties or chemical properties of group 15 elements. So based on today's concept, here are some reasoning questions for you people. Solving such questions will give you idea about how the questions are asked in the board exams. In our next video, we'll be discussing one element from group 15, that is nitrogen, its preparation method, its other properties and its compounds. That's all for the day. Thanks for watching. Have a nice day.